Hey everyone, welcome again to my YouTube channel, and today we are going to solve a new question from our top interview 150 question series, and the question name is threesome. So here what we have been given is that there is an integer array nums, and we need to return the triplets, that means nums I comma nums j comma nums k, such that I is not equals to j, I is not equals to k, and j is not equals to k, and nums I plus nums j plus nums k equals to 0. So what we have been given is that we have been given an integer array nums, and we need to return these triplets in such a way that it satisfies these two conditions. First is that no one index is going to be equal, that means all are going to be different, and their sum is going to be equals to 0. Here it is given that notice that the solution set must contains a must not contain duplicate triplets. So we need to avoid the duplicates. Now let's understand this question and all the approaches which can be possible for it. So let's do this. So here I have taken the first example, and in this first example, what you can think of is the first approach, which is going to be a brute force. And in this approach, what you can do is that you can generate all the possible triplets, because you have already given that I is not equals to j is not equals to k, and k is not equals to j, and this condition is going to be completed by using a 3 for loop. You can use a 3 for loop and generate all the possible sets for this. And what you can do is that you can check if their summation is equals to 0. You can store those values or those three values in a set data structure. By storing this in set data structure, you will automatically satisfy our final requirement. That means the triplets duplicate is not allowed, so you have already removed the duplicates. So this is the brute force approach, but the time complexity is going to be high, which is big O of n cube. So that is not an optimal approach. And you can another approach which you can follow is that what you can do is then you can use a hash table. You will store all the values in this nums, which is repeating as many as time, and after that you will compare it after running the two for loops, that if they are equals to the negative of the value present, then you will what you will do, you will store that value. So here you optimize little bit, but we are going to discuss the most optimal approach. And in this, what we are going to do is that we are going to run a first for loop, and another is going to be a while loop. So let's understand what we are going to do. So what we can do is that first we have been given that our I, and we have been given j, we have been given k. So these are the three pointers which we have been given. First, what we will do, we will run our I index. That means we will iterate in the nums. But before that, in this approach, we need to sort these nums. So we will first sort this. And why we are sorting, you will understand it soon. So by sorting, we will get minus 4, minus 1, minus 1, 0, 1, 2. So this is going to be our sorted nums array. And in this, what we are going to do is that we are going to run a for loop for our I from our starting position to our second last position. And why is that? Because we are going to because we need the two more pointers after that. So these are for our j and k. So that's why we are running it until second last position. So after this, what we will do is that we are left with the j and k pointers. Now, if we are at the first position, let's assume we are at the first loop and our I is equals to 0. Now we are left with the two pointers which are going to vary in our left set, or you can say left array. Now this is the question similar to the two sum, and this is a very interesting scenario that we will get a simple question that is for the two sum. And in the two sum, what we will do is that we can do is that we can take the first pointer at the start, that means here j. We can take the second pointer at the last, that is k, and we can start a while loop where our j is until our j is less than k. We can check if our value is satisfied the condition, then we will insert it, and if it is not satisfied, that means if it is greater, then what we will do, we will decrease our k, and if it is less, then we will increase our j. So this is the approach which we are going to follow. So let's here take a trial what will going to happen. So let's assume we are at the first, that means our I is at the minus 4, our j is at minus 1, and k is at 2. Now in the first loop, what will happen is that when you check the summation, that means you have minus 4, minus 1, and 2, and this is not equals to 0. So what we will do is that we will move to the next. That means we will increase. That means what we will do, we will check if the value is less or high. So we will see that the value is less. So if our value is less, what we'll do, we'll increase our j pointer. So our j comes to this position. But here you can see that the values are going to be same, because for the previous j our value is -1 and the next our value is -1, and the triplets are going to be same. So in place of running the loop, what we can avoid this ultimately. So what we can also check is that until our I and I plus 1 are not different, then we will run an internal while loop and we will move our I until we do not get a value which is not equals to previous g. That's why we can avoid the multiple times loop, and we can also optimize it. And the one very important thing which is going to do is that we can simply avoid the duplicates, and we do not need to use the set data structure. So this is the condition which we are going to use. Similarly for the k, when you see that the next value is similar to k, then you will automatically run a while loop, and we can move the k backward until we get a value which is not equals to k. So this is the approach which we are going to follow. Similarly, we will do for I, and this is going to avoid our duplicates. You will see when we code it. Now here you can see that when we are at the -1, we have moved our j. Finally, we are at the zeroth position. So here you can see that if you sum it, you will get minus 2. So we'll again increase your j, and now you are at the I position. Here if you sum it, it is again not equal. So this is the completion of the loop, and this loop will end. Now your I will increase, and similarly this loop is go on, and it will find the possible sets and save it, and it is going to be not a duplicate. So this is uh, the overall scenario how our code is going to work. Now let's code it, and it is going to be very interesting code. So let's understand it. So let's start by taking the length is equals to nums dot size. Next, what we will do is that we will first sort it, because our first condition is going to be sort. So we are going to do sort nums dot begin comma nums dot end. So we have sorted our nums vector. Now what we need is that we need a vector which we have to return, which is going to be a vector int. Let's take it as ans answer. Now let's run a for loop, and we are going to run it for our I equals to 0, I less than l minus 2. So we are going to run it until our second last index, because we need the two index more for our g and k. Now we are going to run our I plus plus. Now first we are going to remove the duplicates for our I, and in this is important. What we are going to do is that we are going to check if our I is equals to 0. We can move on, because it is the first step. Now next what we can do is that we can check if our I is greater than 0, and let's take in bracket. So if our I is greater than 0, and what it is given that if our nums I minus 1 is equals to, or you can say not equals to, nums I. So in this part we can do is that it is already satisfied that if our, now let's run a for loop. Our int I equals to 0, which is going to be our first pointer, until which value I less than I minus 2, sorry, l minus 2, until I plus plus. Now first we going to check the condition to stop the duplicates for our I value. So what we are going to do is that we are going to check if our I is equals to 0, we can move on. Now the next condition is going to be if our I is greater than 0. That means we moved on from the 0th position, and we can check that if our nums I minus 1 is not equals to I minus 1 is not equals to nums I. That means there is no duplicate. So what we can do is that we can move on. And in this first what we need two pointers, which is going to be our j and k. So we are going to do take these two pointers. First is going to be j equals to I plus 1, and next is going to be k equals to l minus 1. It is going to be l minus 1 every time. Now let's take a vector which is going to store our triplets, and let's take it temp. So let's first store the value for our numSci. So we are going to take temp.prospect numSci. Now what we need to run a while loop. In while loop until our j is less than k, we are going to check, and the condition is going to be if our nums j plus nums k is going to equals to which value, it is going to be negative to the nums I. So if it is equals to negative of nums I, so what we will do, so let's what we can do is that we can also take this negative here, so let it is going to be look good, so we can take it, let's take it compare is equals to negative of nums I. So let's take it here c only. Now if this is the condition, that means our condition is satisfied. So what we need to do is that we need to insert these two values also, that means nums j and nums k in our temp. So we will do this, we will first do for our j and next for k. So we will inserted our j and we have inserted our k. Now what we need to do is that we have to also insert this value in our answer vector. So we need to do ans dot pushback temp. Now, after inserting in our answer, for the next value, we need to remove these two I and j values. So we are going to do temp dot popback two times. Temp dot popback. Now, what we need to do is that we need to also check the condition for our j and k. That means if they are equal, like we have seen before, so we need to move on to avoid our multiple loops. So we are going to check that if this while is satisfied. So we are going to first check if our j is less than k, and our main condition, which is going to be nums j is equals to nums j plus 1. So if the next one is equal, so we can simply increase our j. Now similarly we do for our k, that is if our k is equals to k minus 1. So what we do, we decrease our k minus minus. Now for the condition when these two are not available, that means there is no duplicates and we have already inserted the triplets, what we need to do is that we have to move on to the next index for our both j and k. So what we will do, we simply increase our j and decrease our k. Now we can move to the next condition, that means else if, and here what we can check is that if our nums j plus nums k is greater than c. So let's do for greater than c. So if it is greater, so what we need to do, we need to decrease it, and how we can do that, we can do that by decreasing our k. So we simply decrease our k. Now in else part, if it is less, so we have to increase it, so we can do j plus plus. Now finally what we will do, we return our answer, return ans. So this is the code, let's try to run this code. So it is accepted. Now let's submit this. Okay, so it is successfully submitted. So this is the question for today. So this is an interesting and very important question. Here you can clearly see that in our first for loop, we have made this in this while loop the two sum problem. We have reduced this question three sum problem to two sum problem by using the first for loop. So this is an important question. Thank you all.